Hello students, as we discussed about two types of atomic spectra, absorption spectra and emission spectra. Let us discuss spectrum of hydrogen atom because the spectrum of hydrogen atom has played a very important role in the development of atomic structure. So first let us discuss the spectrum of hydrogen atom. The spectrum of hydrogen atom can be obtained by passing an electric discharge through the hydrogen gas, which is taken in the discharge tube under low pressure. So when we apply an electric discharge, it starts to emit radiation. Then this radiation is made to pass through a prism, and we found that a spectrum is obtained due to the splitting of radiation through a prism, and this series of colors we will be getting. So this spectrum is called as emission spectrum of hydrogen, and the spectrum is observed with the help of spectroscope. The spectrum of hydrogen consists of large number of lines appearing in the different regions of wavelength. We can say that there are series of lines. Some of the lines are present in the visible region, some are in the ultraviolet region, and some are in the infrared regions. These series are named after the name of the person who has given the details. That is, the series are Lyman series, Balmer series, Pascal series, Brackett series, and Fun series. In 1885, J.J. Balmer developed a simple relationship among the different wavelength of the series in the visible line in the hydrogen spectrum. He has given a relationship between the wavelength and which is shown here, that is 1 by lambda is equal to R into 1 by N1 square minus 1 by N2 square. Here lambda is a wavelength, R is a constant which is called as Rydberg constant. Its value is 109,677 centimeter inverse. Here N1 and N2 are the integers. In such a way, N2 is greater than N1. So this N1 and N2, these are actually energy levels. Let us discuss with this chart. It is observed that the different spectral lines in the spectrum of hydrogen atoms are Lyman series, Balmer series, Pascal series, Brackett series, and Fun series. These series of lines, that is the spectral lines, is observed to be in the particular regions. That is, Lyman series is found in the ultraviolet region, Balmer in the visible, Pascal in the infrared, Brackett in the infrared, and FUD in the infrared. So when we compare the equation that is given by the Rydberg, in this equation for each series it is given represented by this formula. Here N1 and N2 are the integers. So for the case of Lyman series, N1 is 1, N2 is 2, 3, 4, 5. That means it can be from second to 1, third to 1, fourth to 1, 5 to 1. In the Balmer, N1 is 2, but N2, I told you N2 is greater than N1. So N2 will be 3, 4, 5, 6 and so on. So this can be better explained through this diagram. So in the Lyman series, you can find that the transition takes place, that means the electrons transition takes place from, it can takes place from infinite to first position, that means n infinity to n1, n7 to n1, n6 to 1, 5 to 1, 4 to 1, 3 to 1, 2 to 1. So that's why depending upon the transition, if the transition takes place from second to 1, then n1 is 1 and n2 will be 2. If the transition takes place from 3 to 1, then n1 will be the 1 and n2, that is the final position, that is n3 there. So this is the Lyman series. Balmer series, in that also you can see the transition, and Balmer series comes in the visible region. Therefore, we can find that these will be showing the colored lines. Pascal, that is in the infrared region, bracket in the infrared region, and Fun in the far infrared region. So this is all we have observed in the case of a spectrum of, that is a line spectrum of hydrogen atom. So, the knowledge of the line spectrum for hydrogen atom plays a very important role for Niels Bohr to give his Niels model of hydrogen atom. So, we will be discussing Bohr's model of hydrogen atom in the next video. Thank you everyone.